screen now?
Yes, sir.
আমি আজি নেক্সট আৰু এখন পেপাৰ আছে কি ফূৰ্তি হ'ল নি বাৰু ল'ৰাখনৰ গম পাই গম পালি নাই নাই 5th সেমিষ্টাৰ এটা এক্সাম আছে মোহিত
Yes, sir.
অভিক
কি বস্তু কিয় দি আছে
নাই এক্সাম 5th সেমিষ্টাৰ যিটো এটা পেপাৰ বাকী আছিলে হয় নাই
গম পালো নহয় বুলি
অ'কে নহয় নহয় বুলি গম পাই ফূৰ্তি হ'ল নেকি ল'ৰাবিলাক আজি নাই যে ক্লাছত
স্যাৰ তাহাঁতৰ সব কনসেপ্ট ক্লিয়াৰ আছে চাগে
okay let it be start or electronics okay power electronics basically what is exactly power electronics is power electronics is nothing this is a branch of electronics but which mainly deal with this with the power device power with the so this is a multidisciplinary thing where these electronics things are there, control things are also there, and electronics. And it has this this relation. Somebody is trying to join.
আপুনি
Okay, okay, okay. মোৰ ফেনখন চলাই আছিলো এইটো কাৰণে
বাইক চলাই আছে
এতিয়া হোৱা নাই
লাগি আছে
নাই নাই ফেন চলাই আছিলো okay. Multidisciplinary things has the relation to with this electrical circuit theory system signal processing simulation and computing electronics solid state physics electromagnetics and power system as well ঠিক আছে multidisciplinary হয় আৰু ইয়াৰ and it has the relation with the all such types of fields of different fields and the interdisciplinary nature power electronics is the interface between the electronics and power interface between the electronics and power in is this triangle then see then power static and rotating power equipments and a continuous and discrete control all are in the electronic power electronics okay now power electronics technology actually what is it? As the technology for the power semiconductor devices and integrated circuit develops the potential for application of power electronics become wider the power semiconductors actually power when we are talking about the power electronics basically we're talking about the power devices that has been made by this semiconductor devices. Okay, and we'll discuss how these devices are being used for power converter things. Okay, as the technology, the power semiconductor devices or power electronics converter falls generally four categories. Okay, there's four categories. One is AC to DC converter, rectifier, DC to DC converter, DC chopper, DC to AC to AC converter, AC volt, and DC to AC converter, that is inverter, right? And the design of power electronics converter circuit requires the design in the power and control circuit. Current harmonics data generated by the power converter can be reduced or minimized with a proper choice of the control strategy. Dealing with the high power system, and we also need to think of this power and other things, and this is by the electronics devices channel. Because high power, higher the power, higher will be the harm. Proper management is most required thing. How will you manage this thing? Means you need to you should have some control on it. These high power things, and that control can be done with this devices. Okay. Next, power electronics application. What are the applications? This is just an overview. See, what the applications, the power electronics defined as the application of solid state, that is solid state in semiconductor devices, electronics for the control and conversion of electric power. Have already founded an important place in the modern technology and are now used in great variety of high power products, including heat controls, light controls, electric motor control, vehicle propulsion system, di- uh, direct current system, etc. Okay. And if you see, if you are talking about, if you think of this one, what are the power electronics switching devices? These are there. You can classify if you, but some also uncontrolled, and we cannot turn off and turn off for these switching devices. Like for power drive, we cannot control turn on and off, and control turn off. We can turn on, but only turn off. That is thyristors. You may have, that will discuss it. Basically, have four there, 4 layers of semiconductor. Control turn characteristics. This is power and MOSFET. Gate turn off, IGBT insulated gate by bipolar transistor. Then continuous gate signal requirement. This gate requirement signal is for this one, where we need the BJT, MOSFET, and IGBT. Pulse gate requirement, where we need SCR, that is silicon control rectifier, and GTO. Uh, Gate turn off, bidirectional current capacity, capability, that is strike. We'll discuss these things. And unidirectional current capability, that SCR, GTO, BJT, MOSFET, and this thing we can devise. But if you see, basically we can classify it into these three category. One is uncontrolled turn on and off, control turn on, uncontrolled turn off, and then control turn on and turn off. These are the basic things. Next is, let's forget about the history, don't know. And now we'll discuss what a power diode. What is power diode? The power diode has a PIN structure. Okay, unlike this power, the normal diode that is have only pin star, P and N type star, means it the P type and N type semiconductors are joined. Okay, here this is something different, where the PIN structure, where there is a insulating layer, means or not insulating, intrinsic semiconductor layer in between P type and N type material. Okay, structure. Here this I in PIN stand for the intrinsic semiconductor layer to bear the higher level and reverse voltage as compared to the single. Why it is used? To bear, so that it can bear the higher level of reverse voltage, and that will show this one in the next figure will show. However, the breakdown of this intrinsic layer is that that it adds noticeable resistance during noticeable resistance during the এটা যদি থাকি যায় intrinsic layer কি হয়, it will always provide forward bias ইয়াৰ resistance খুব বেছি হয়, ঠিক আছে, resistance বেছি হয়. When resistance is more, that means once the resistance is more, then this power heat dissipation will be more, power loss will be more. Okay, energy loss, and that losses in the form of heat. So when we are using this power diode, we also need to arrange for this cooling arrange. We need to arrange the cooling arrangement, do the cooling arrangement, so that it does not cool কৰি ৰাখিব লাগিব. To make it cool, we need to do some extra things on that. Thus, the power diode requires a proper cooling arrangement for the handling a larger power dissipation. Okay. Power diodes are used in numerous applications, including rectifier, voltage clamper, voltage multiplier, and etc. Power diode symbols are symbol is but same. However, though the structure is different, but its symbol is same. And if you see this one, this is the symbol of the power diode, same like, but structure is different. Okay, structure is what? Suppose if it is highly doped, and if these are highly doped and these are very lightly doped, as it is lightly doped as compared to this highly doped semiconductors, we can consider it as a intrinsic kind of thing. Okay, দুটা পিটাৰ মাজত এটা intrinsic material, because this is the lightly doped things. Okay, so now, but at the same time, the construction of this diode also use two different layer, unlike this other two extra layer, unlike the normal semiconductor layer. These two are use the guard ring and coating of silicon dioxide layer. Okay, that is guard ring. Guard ring are the P type, are of P type that prevents their depletion layer merge with the depletion layer of the reverse bias PN junction. গাৰ্ডিংটো কি কৰে, পি টাইপ হয় আৰু পি এন জাংচনৰ ডিপ্লেশ্যন লেয়াৰটো মাৰ্জ হৈ যোৱাত মানে প্ৰটেক্ট কৰে. The guarding prevents the radius of the curvature of the depletion layer boundary to become too narrow, which increases the breakdown strength. A coating of silicon dioxide layer helps in limiting the electric field at the surface of the power diode. Why these two are used? This is the explanation for this. While this construction of power diode is made. Okay. Next, now when we are depending upon the size of the that intrinsic layer between p-type and n-type material, what will be the effect? How if this size is means it is thick, if the intrinsic layer is thick, what how this will affect in the the diode performance? If it is layer is somewhat thin, then what will be the device performance? That we'll discuss here. See, if the thickness of the lightly doped intrinsic layer, that is layer, is greater than the depletion layer with at background, যদি background যদি intrinsic layer width to যদি depletion layer width বেশি হয়, at that moment what will do? No punch through the power diode. Power diode মাজেদি punch নহয়, মানে leakage নহয়. There is no leakage. This means the depletion layer has no punch through the lightly doped N layer. Okay. Then if the thickness of intrinsic layer is less than the depletion layer width at breakdown, if it is less than, then punch through the power diode. Punch through the power diode, that means you will get some leakage through the power diode. Next is characteristics of power diode. The characteristics can be the characteristics of power diode can be studied two way. One is voltage ampere voltage, means VI characteristics or IV characteristics you can say. Another is called turn off characteristics. How it is behave when you are when you turn off this power diode. This will depends, and it is called reverse recovery characteristics. We will study these two characteristics here. Okay. First thing, this is same like the normal diode, but has some effects is that we'll discuss in next slide. It is same, see, forward condition, forward conduction here, and then reverse leakage current and avalanche breakdown. Okay, that's all. Then what, and its explanation is here. The cut-in voltage in the is the value of the minimum voltage for VA, that is anode voltage, to make the diode work in forward conducting mode. That means VA means what? That is the forward voltage. Now cut-in voltage of single diode is 0.7 volt. See, single diode here, it is referred to the normal diode, this normal PN junction diode. Okay, diode is 0.7 volt, while in power diode it is 1 volt. For power diode, this voltage is 1 volt. So it's a typical forward conduction drop is larger. যদি মানে কাটিং ভোল্টেজটো যদি বেছি হয়, that means what is voltage drop, forward conduction voltage drop to বেছি হ'ব নাই? হ'ব. Okay. Under forward bias condition, single diode means normal diode current increases exponentially and then increases linearly. In case of the power diode, it almost increases linearly with the applied voltage, as all the layer of PI and remains saturated with the minority carriers under forward bias. Yeah. Actually, I am on a class, so can you please call me back in the evening sometime? Okay. sorry, high voltage current produces the results in voltage drop which masks the exponential part of the curve. As condition, small leakage current follows due to the minority carriers until the aberrant background appears. See, now we'll see the characteristics of power and how these things are going on. How it behaves over time, how the voltage, how this current changes with time, how this voltage changes with time, what are the power losses here. And we'll discuss these things. See, after the diodes comes to the null, forward diode comes to the null, the diode continues to conduct in the opposite direction because of the presence of stored charge in the depletion layer and the P or N layer. The diode current flows for a reverse recovery time, that is TRR. It stores some because we make this depletion layer larger, we make this and we make the diode such a way that more charge can be accumulated by putting an intrinsic layer in between P type and N type. When you switch off the power, when you off the forward voltage, at that moment what will do, there will be a accumulation of charge in the this depletion region, and it keep following for some time stored charge carrier and depletion layer and p type. The diode current flows for a reverse recovery time. It is the time between the instant forward diode current becomes zero and the instant reverse recovery current decays to the 20 reverse maximum value. Means current, okay, forward current you have, then you switch off and then the forward current gets zero. Forward current reaches zero. At that moment what happened? There will be a charge recovery, means there will be a charge accumulation at the junction, at the what called depletion layer region, and that charges will start following opposite direction where as it was following earlier in the when the মানে কি ফৰৱাৰ্ড বায়াসত যিটো ডাইৰেকশ্যনত কৰিছিলে অফ কৰি দিয়াৰ পিছত সেই চাৰ্জখিনি অপজিট ডাইৰেকশ্যনত মুভ কৰিবলৈ লয়। অপজিট ডাইৰেকশ্যন যদি মুভ কৰে আমি কাৰেণ্টটো এটা নিগেটিভ ডাইৰেকশ্যনত পাওঁ, ঠিক আছে। এণ্ড ডেট পাৰ্ট ইজ কল্ড দিছ ৰিভাৰ্চ ৰিকভাৰী টাইম। ৰিভাৰ্চ ৰিকভাৰী টাইমটো ক'লৈকে কনচিডাৰ কৰা, ইয়াৰ মেক্সিমাম ভেলুৰ পৰা মানে 75% মানে 25% পৰা কি কৈছে ৰিকভাৰী কাৰেণ্ট ডিকে হ'ব কিমানলৈকে 25% অফ ইটছ ৰিভাৰ্চ 25%লৈকে যেতিয়া ৰিকভাৰী হ'ব মানে যাব তাৰলৈকে যিখিনি টাইম হয় সেই টাইমটোক ৰিভাৰ্চ ৰিকভাৰী টাইম। তাৰমানে ইয়াৰ মেক্সিমামৰ 25% পোৱালৈকে মানে যিমানখিনি টাইম লাগিব। Start from here, then it gets a maximum, then start decaying, কারেন্টটো ডিকে হয়, ঠিক আছে। At this moment and this is called this reverse recovery time. 25% মানে maximum পৰা 25% হোৱালৈকে কৰে, because it gets zero at this point, but we have not considered this time up to this reverse recovery time. We have considered this time up to this point where the 25% of maximum has fall, ঠিক আছে। নেক্সট আহিলে ইয়াতে কি হয়, ইয়াৰ আমি এইখিনি চাওঁ। হোৱাট ইজ দিছ? দি টাইম TA is called the charge stored in the depletion layer remove. Depletion layer চাৰ্জখিনি যিখিনি আছিলে এই টাইমটোত ৰিমুভ হয়, ঠিক আছে। and TB charge from the semiconductor layer is removed. ইয়াতে depletion layer ৰিমুভ হয় এতিয়া semiconductor যিখিনি layer আছিলে সেইখিনি remove হ'ব. And the shaded area in the figure represents the stored হেল্ল' একেবাৰে লাষ্টৰ ঘৰটো মানে এইটো আপুনি গড়াৰ বদলি এণ্ড হয় মানে ইয়াতে আমাৰ ঘৰটোতে শেষ আৰু আপুনি গেট এখন পাব নীলা এইটো আৰু এইফালে আৰু ৰাস্তা নাই মানে আমাৰ ঘৰটো শেষ চিধা চিধি আপোনাৰ চিধা চিধি Okay. Now this stored stars Q মানে amount determine কৰে ঠিক আছে remove during the reverse recovery time এইটো remove হ'ব লাগিব yes and this is the product of voltage and current forward voltage and forward current and this is so that maximum current is maximum power loss is occurred when at the time during the time TB. So TB time to ketia when you remove these charges from semiconductor layer. Okay, this device itself removing, and at this time this maximum power loss has occurred. Okay. Then another was that what was that? That is reverse recovery time characteristics, right? Reverse recovery characteristics. This one, second turn off characteristics or reverse recovery characteristics. And that reverse recovery characteristics is look like this. And this reverse recovery characteristics can be classified into two ways. One is called soft recovery, another is called abrupt recovery. In case of soft recovery, what will do? Here this S is the main factor here. And that S factor is the is basically give you whether it is soft recovery or abrupt recovery. Now see here, if you can see this TA is the time, same thing. TA is the time where for time to remove the charges from the depletion layer, and TB is the time to remove the charges from the semiconductor layer. Okay. Then if TB by TE TB by TA is called the softness factor or S factor, and depending upon this TA ratio of these two, TB by TA, you can say whether this is the soft recovery or abrupt recovery. Okay, this S factor measure the voltage transient that occurs during the time of the diode recovers. Okay, and then S factor, if S factor is equal 1, reverse recovery process, and that is called soft recovery. S factor is less than 1. See, it's large oscillatory over voltage, that is snappy recovery or fast recovery, that is called abrupt recovery. See, equal or if it is equal or greater than, then you can say it as a soft recovery, because TB is greater than, that means TB is greater than TA. When the TB is greater than TA, greater than equal TA, then it is called soft recovery. When this TB is less than TA, then it is called abrupt recovery. Okay. Any doubts so far?
No, sir.
অ'কে, সেইটোৱে আৰু বেছি নাই, বেছি পঢ়িব লগা নাই। কিবা ডাউট আছে যদি কাৰোবাৰ সুধিব পাৰা, নহ'লে আজিলৈ হৈ গৈছে ক্লাছ। একেদিনাখনি বেছি ভাল।
Thank you, sir.
আৰু নাই ন ডাউট? আজি বাৰু কোন
নাই।
থাকিলে?